Chapter 4 is all about decimal notation. And you're probably familiar with the word decimal notation, and chances are you've probably used it at some point in time also. It was actually introduced, or was developed in Europe in the late 1500s and early 1600s, and then it was used, from that point on in various forms. And so we're going to talk about a few topics here about decimal notation, order and rounding, section 4.1, and section 4.2 about addition and subtraction, then multiplication and division, and then converting from fraction notation to decimal notation, and then estimating, and then last, applications and problem solving. So in section 4.1, we have four different objectives. One is the decimal notation and writing a word name, and then converting between decimal notation and fraction notation, and then give them a pair of numbers in decimal notation, tell which is larger, so it's about order, and then how to round decimal notation. So anyway, we've got a few topics here that we need to cover, and as always, please make note of the new words for your math vocabulary, because obviously we'll be using them again in the future. So you want to have a good understanding what the words mean. First, let's talk about the set of arithmetic numbers, or non-negative rational numbers. And of course, the rational number is basically a fraction, 3 divided by 7, for example. So these arithmetic numbers consist of the whole numbers, 0, 1, 2, 3, 4, 5, etc., and fractions like 1/2, 2/3, 7/8, 17/10, and so on. Note that we can write whole numbers using fraction notation. For example, we know that 3 can be written as 3 divided by 1. And so we studied that in chapters 2 and 3. So in this chapter, we'll study the use of decimal notation. And so decimal comes from a Latin word decima, meaning a tenth part. And although we're using different notation, we're still considering the non-negative rational numbers. In other words, the numbers we just discussed. Using decimal notation, we can write 0.875 4/7/8, or 48.97 as 48.97/100. In other words, rational number notation and decimal notation is equivalent. We begin with some very simple ideas here, decimal notation and word names. And as an example, one model of the iRobot Roomba robot vacuum cleaner with Wi-Fi connectivity sells for $697.99. And the dot in 697.99 is called a decimal point. Since $0.099 or 99 cents is 99th of a hundredth of a dollar, it follows that 697.99 is equal to $697.99, or $0.099. And also, since $0.099 or 99 cents has the same value as 9 dimes and 9 pennies, and 1 dime is a tenth of a dollar, and 1 penny is a hundredth of a dollar, we can write in expanded notation now. 697.99 is 6 times 100, that's 600. And then for the tenths, it's 9 times 10. And for the ones, it's 7 times 1, plus 9 1/10, plus 9 100, 9 times 100. Okay, so that's an expanded notation. So here's a place value chart. It's a good idea to remember that. So we have the hundredths, the tenths, and the ones, and then the tenths with the th at the end, and the hundredths with the th at the end, and the thousands, and the 10,000th, and the 100,000ths. So in a way, you're familiar with this. You have seen this before, I'm pretty sure, but here it's more direct. So when we look at a number like 3.46583, What does that mean? It means 3 ones, and it means 4 tenths, and 6 100ths, and 5 thousandths, and 8 10,000ths, and 3 100,000ths. Or 3 and 46,583 10,000ths. So 3 and 46,583 10,000ths. That would be, of course, a fractional part. We read both the decimal notation and the fractional notation as 3 and 46,583 100,000ths. Whether we write it this way with a decimal point or in the fractional notation, we read it this way. We can also read this decimal notation as 3.46583. And everybody knows what that means, 3.46583. We simply read the numbers as they appear after the decimal point. Again, the point is the decimal point. And I'm pretty sure you've seen all of this before. So here are the instructions for writing a word name from decimal notation. Here's a number, and first we write a word name for the whole number, the number to the left of the decimal point. In this case, 397. Then we write the word and. The and stands for the decimal point. 397 and. Now comes the fractional part. 6 and tens, hundreds, thousands. So the 685 thousandths. So we have 397. That's for the whole number part. The and stands for the decimal point, and then 685 thousandths. So we practice this some more in some of the examples coming up here in just a moment. Let's look at life expectancy. The life expectancy at birth in South Africa in 2016 was 61.6 years for males and 64.6 years for females. Write word names for 61.6 and 64.6. So for 61.6, we write 61, 61, and that's for the decimal point, 6 tenths. And for the other one, we write 64 for the whole number, 64, and 6 tenths. In example number 2 is a 10,000 meter record. Almas Ayana of Ethiopia holds the women's world record for the 10,000 meter run, 29.2908 minutes. Write a word name for this expression. Again, first we look at the whole number part. That is 29. Then for the decimal point, and. Now to see which position we have here, which place value we have tens, hundreds, thousand, 10,000ths. So we have to write this as and 29. 29. So 29 and 2,900. 908. 10,000s. So in other words, before we begin to write it down, you have to determine what we're dealing with: tens, hundreds, thousands, 10,000s, etc. So 29 and 2,908 10,000s. That would be the word name for this expression. For example number 3, we have 245. 245 and so tenths and hundreds, so and 89 hundredths. And for example number 4, we have 34 and so tens, hundreds, thousands, 10,000. So there would be 64 10,000s. Again, ones, tens, hundreds, thousands, 10,000s. That's why it ends 64 10,000s. For number 5, for the whole number, we have 31,079. 31,000 79. 79. And now we have tens, hundreds, thousands, and 756,000 and 756 thousands. In section B, we're going to learn about converting between decimal notation and fraction notation. So to convert from decimal to fraction notation, we count the number of decimal places. So in this case, 4.98, there are 2 decimal places. And then we move the decimal place to the right, as many places to the right, and write the answer over denominator with a 1 followed by the number of zeros. So in other words, since we have moved to 2 places, a 1 followed by 2 zeros, 498 100ths. Pretty simple process, and so let's look at some examples. Here's a guided solution. So 0.896 or 896 thousandths, as you will see. So we move the decimal point 3 places. So then we write 896 divided by 1 followed by 3 zeros. And that's it. As I said, it's pretty straightforward. So in the same way, 23.78. So here we write that as 23, it moves the decimal point 2 places, 78, and write a 1 in the denominator. Since we moved the decimal point 2 places, we write it as 100. In a similar way, we write this number as 5, 6, 7, 8, 9. And since we moved the decimal 1, 2, 3, 4 places, we write a 1 and a 0 followed by 4 zeros. So it's 56,789 10,000ths. And for exercise number 9, we have 19. So here we move the decimal point 1 place. Where you write 19 divided by 1, followed by 1 0, or 19 tenths. So all you have to do is count the number of places you move the decimal. 1, 2, 3, 4 in this example. So we have a 1 in the denominator followed by 1, 2, 3, 4 zeros. To convert from fraction notation to decimal notation, when the denominator is 10, 100, 1000, 10,000, and so on, we count the number of zeros, like in this example, 8,679 divided by 1,000, so there are 3 zeros, and then we move the decimal point, which is implied, of course. There is no decimal, but it's an implied decimal that follows the 9. We move it 3 places to the left, because there are 3 zeros in the denominator. And then we simply leave off the denominator. In other words, 8,679 thousandths is 8.679. Let's do some examples. Here's the guided solution example. 743 divided by 100, so we count 2 zeros in the denominator. So we have 743, there are 2 zeros. The implied decimal after the 3 is moved 2 places, so it goes between the 7 and the 4, so we move it 2 places. And so then that 743 divided by 100 is equal to 7.43. So sometimes there's a decimal and sometimes there's not. Again, if it's a whole number, there's an implied decimal after the last digit. In example number 11, we have 406 divided by 1,000, so we have 406. Again, the implied decimal is here. So we move it 1, 2, 3 places, so it goes to in front of the 4. So we move the decimal in front of the 4 because there are 3 zeros. This will then be 0.406 or 406. Here's the implied decimal, 1, 2, 3 places in front of the 4, and then we add a 0 just to make it clear. In number 12, we count 1, 2, 3, 4 zeros, and the number is 67089. The implied decimal is here, so we move it 1, 2, 3, 4. So therefore, this as a decimal is 6.7089, because we moved it 1, 2, 3, 4 places. For number 13, we have a 9, which is followed by decimal. We move the decimal one place to the left, so this then becomes 0.9. To write 4 3/10 in decimal notation, we note that this is equal to 4 plus 3/10. Now we convert 3/10 to decimal notation. And so here the decimal is after the 3, we move it one to the left, so that becomes then 0.3, and that is then equal to 4.3. Similarly, number 15, this is 283 plus 71 100ths. When we look at the fractional notation, the decimal follows the 1. There are 2 zeros in the denominator, so we move the decimal 2 places to the left. So this then becomes 283 plus 0.71, which is 283.71. In number 16, it is 456 plus 13 1,000ths. So that's equal to 456. And here the decimal point follows the 3. So it's 1, 2, 3 zeros. So that then is 0.013. Again, we move the decimal place 1, 2, 3 places. So one step in front of the 0 that we need to add on the left side here. So that is equal to 456.013. 456 and 13 thousandths. The next section is about order and comparing numbers in decimal notation. And as you will see, it's really pretty easy to compare two numbers in decimal notation. In a way, it's easier than dealing with fractions, other than fractions are 10. So to compare two numbers in decimal notation, start at the left and compare corresponding digits moving from left to right. If two digits differ, the number with the larger digit is the larger of the two numbers. To ease the comparison, extra zeros can be written to the right of the last decimal place. Well, we look at that in a moment, what that means. So number 17, we asked which number is larger. To make it easier to compare these numbers, since one number only has two decimals, the other one has 3, so we can write this. The first number is 2.040, and this number is, of course, 2.039. So the 2's are the same. The next is a decimal point, okay, and then the next digits are the same also, 0 and 0. But now we have 4 for the first number and a 3 for the second number. Therefore, we know that the first one is a larger number, so 2.04 is a larger number. Or you can say 40 is greater than 39. For number 18, to have the same number of decimals, we can write the first number as 0.060, since the second has 3 decimals. And so here's the second number, 0.008. So let's compare digits. 0, 0, it's the same. There's a decimal point. And then with a 0 and a 0, it's the same also. Now we have 6 for the first number and a 0 for the second number. Since 6 is larger than 0, the larger number is the first one, 0.06. Another way of looking at it is to say, okay, we're having thousands here, and this represents 60 thousands, and this represents 8 thousands, and 60 thousands is certainly larger than 8 thousands. So that's why the first number is the larger of the two. Number 19, there's the same number of decimals for each number. We are going to write the first number as 0.50. And the second number we leave as 0.58. Now we're comparing digits. 0 and 0 are the same. There's a decimal point. The 5s are the same. Now here we have a 0 and here we have an 8. And since 8 is larger than 0, the second number is a larger number. So 0.58 is a larger number. And again, if you think in terms of what this represents, this is 50 hundredths, this is 58 100ths. 58 is larger than 50. So this is a larger number. Number 20, again, there's the same number of decimals. We'll write this as 1.0000, 4 decimals, and the second number is 0.9999. In this example, we look at the first number. 1 is larger than 0, so we're all done. The larger number is 1. If you compare 1 and 0. In number 21, we look at the 0 for the whole number. That's the same. There's a decimal point. Then we have an 8 in the first for the tenth position, and here we have 0. 8 is larger than 0. Therefore, the larger number is 0.8989. Now here there's some clarity. Let's write the second number with the same number of decimals. So the first number is 21.006, and the second number is 21.050. So now with the same number of decimals. We compare digits. 2 and 2 is the same. The 1 and 1 is the same. There's a decimal point. The first digit is a 0 and a 0, and then there's a 0 and a 5. And since 5 is larger than 0, the second number is a larger number, 21.0505. Next is rounding, and that's pretty important that we learn how to do that properly. So we're rounding a decimal notation, but to round to a certain place, locate the digit in that place. Consider the next digit to the right. If the digit to the right is 5 or higher, round up. If the digit to the right is 4 or lower, round down. What does that mean? Well, when we look at number 23, we're told to round to the nearest tenth. So the 10th position is where the 7 is. The 7 is followed by 6, which is 5 or higher. So in other words, we round that up to 2.8. In number 24, the 10th would be the 8 here. It's followed by 5, that means we round it up, and this will be 13.9 when we round it up. In number 25, we have 234.448. The tenth is this 4 here. And since a 4 is followed by a 4, we round down. In other words, we leave the 4 as it is. So it's 234.4. And in number 26, the 10th position is here. So it's followed by 0. So this then will be 7.0. In number 27, this is the 10th. It's followed by, the hundredths would be the 3 here. And the 3 is followed by 6. So that means we round it up to 0.64. In 28, the hundredths is here, and the 3 is followed by 4, so we don't do anything, we simply leave it at 7.83. We round down. In number 29, the hundredths is 7 here. Since it's followed by 5, we round it up to 8. In other words, this will be 34.68. And in number 30, the hundredths position is here, 0.02, 5, followed by 5. So that means we round the 2 up to 3. This will be 0.03. In number 31, we are supposed to round to nearest thousands. So tens, hundreds, thousands, it will be here. Since the 3 is followed by 4, we round down. In other words, this will be 0.934. Number 32, the thousands is here. It's followed by an 8. This will then be 8.004. Because the 3 is followed by a number greater than 5 or greater. In number 33, the thousands is here. It's followed by 9, so we round it up to 43.11. Since this one is followed by 9. In number 34, it's 37.4005. The 0 is followed by a 5. In other words, we round this up to a 1. 37.401. For number 35, we are supposed to round this number, 7,459.3548, to the nearest thousands. The thousands are here 3, tens, 100,000 is a 4. Since the 4 is followed by an 8, we round the 4 up to a 5. The answer is 7,459.355. For number 36, we are supposed to round it to the hundredths, tens, hundredths. So here we're looking at the 5 followed by 4, so we round it down. And the answer is 7,459.35. And when we round to the nearest tenth, we're looking at the 3, it's followed by 5. So this will be 7,459.5. 4. We rounded the 3 up to 4 because the 3 is followed by 5. And the nearest 1, well, the 1 would be here, the 9 would be in the 1 position, and since it's followed by 3, we round it down. This will be 7,459. The nearest 10, the 10 is here, 1s, 10s, and so on. So here's the 10s. And since the 5 is followed by a 9, this will be 7,460. And here it says caution, tens is not the same as tenths. We had the tens up here. And the nearest 100, will be 400, is followed by 5. This will then become a 7,500. And the nearest 1,000 would be 7 followed by 4, so we round down, and this will be then 7,000. You may want to think this through on your own, and but I'm sure you come up with the right answer if you did it on your own. So there are the answers. And this is the end of section 4.1.